BrainQCNet is an app to detect the quality of scans. For each volume, it will return a prediction. If it's 1, it means the scan is damaged. If it's 0, it means the scan is high quality. So let's see how it works on Nvidia GPU machines with CUDA installed. So in this short tutorial, we will focus on the two steps, step 3 and step 5. So the first step, step 1, is to install Docker. So you have the documentation here, it's very well explained. Second step is particular for GPUs, so you need to install Nvidia Container Toolkit. So I just share with you the two links here for Linux system or Windows system. And in step 4, you download the best model actually, so you have the link here. You will unzip the saved model.zip that you just downloaded, and you move this saved models folder to a chosen folder on your machine. Okay, so in step 3 that we will perform on our machines, we will pull the image BrainQCNet from the Garcia ML repository on Docker Hub. So here we use the latest version, but you can specify a specific version that you may want to use, and it's very recommended to make your work reproducible. Next, we will run this command, so the docker run command, only for the participant level because this is a short demo, so we won't perform the whole pipeline, but it's very straightforward to go from the participant level to the group level. You only have to change the participant word to the group word in the command line. So let's have a closer look to this command. So the docker run command will create a container on your machine with all the environment necessary to run BrainQCNet. It's very important that you specify this flag, GPUs all. So if you want to use only one GPU, you can specify integers corresponding to the number of GPU you want to use. So I invite you to read the Docker documentation on this GPU flag if you want to do something more personalized. And next we will mount 3 volumes. So the first one is the BIDS data. So you need to change here the path to your own full path to this BIDS dataset. It will be mounted to the /bidsdir directory in your container. And we mount it in read-only mode because we don't want the container to write actually into this directory. We only want it to read from this directory. The second volume we will mount is for the output. So here again, you need to change this path for the correct one that will be on your machine. It will be mounted in the /outdir folder in the container, and it's in read and write mode by default, because here we actually want that the container writes into this directory. And the third volume we will mount is the saved models. So it's the folder where your models are stored. So you just moved your saved model folders in step 4. So just enter the correct path here, and it will be mounted in the container in /saved models. And here again we use the read-only mode to be able to protect in a way from writing inside this folder by mistake. Okay, next we call the app BrainQCNet. So here again you need to enter this full name. And we call the 3 parameters that are very common to all BIDS app. So the first one is the BIDS directory. So here we consider the inside of the container, so this will be /bidsdir. Next, the output directory, so it will be /outdir. And finally, we call the participant level. Next, you can just add many options that are defined in your run, well, in the run.py script. You can see the script in the code in the other repository that shares the code. And yeah, and that's all. So let's see how it runs and how it performs on two different machines now. The first machine we will perform the experience on is a graphic card GeForce GTX 1060 with 6 GB of memory. So we will first pull the image from the GarciaML repository, BrainQCNet. So really be careful to use this one because this is the one working on GPU. And next we will launch the docker run command by specifying the correct paths to our volumes. Here we are. So next it launches a Met2Image that will just cut your volume into slices. Next it will process each slice to get local predictions and gather all of these local predictions to generate a global prediction for your volume. So you can have everything saved into a log folder, but during the group step, it will gather everything into a CSV file. So here it processes one scan in 1 minute 30 seconds, which is very fast. The second machine we will use is a GeForce RTX 3090 with 24 GB, so much more powerful than the first one. So we already have the image installed on it, and we just adapt the correct paths to the volumes and the correct image name before launching the command. Okay, and so here this machine is much more powerful, so the time is very reduced. So in 50 seconds, your scan will be processed and you will get your prediction. So you see that on GPU machines with Nvidia and CUDA installed, our app is clearly fast, depending of course on the memory available and the type of GPU. You may have longer or shorter processing time. So be sure that you have this sufficient amount of memory to run our app. And above all, enjoy using BrainQCNet.